Hello everyone. Thank you so much for joining me today. Another bright day. We're going to be doing something really fun today, which is optimizing performance of a video player app. I hope you're all doing great. Thank you so much for joining me on this Wednesday morning or Wednesday evening, whatever time it may be in your time zone. I appreciate you coming here. And now, if you're here and awake, tell me in the chat that you're here. Pepper has also joined us today. Okay, let's see. Are we live on YouTube? Are we live on Twitter? Here, I see Aziz is here. Yay! Thank you, Aziz. Thank you for joining me. Let me pull up my Miro board until then. Mihir is here and awake. Yay! Thanks, Mihir. Thank you for making me feel like I'm not talking to just myself. I appreciate you. Okay, so today's session is going to be really fun because we're going to be talking about performance optimization of a React app. Now, there is a lot to cover in this topic, so today's stream, I'm going to try to keep it around an hour, hour and a half. I'll go into the concepts of performance optimization. As a recap, this is a best practices series that I've been doing since Monday, which is actually a talk that I gave at StrappyConf earlier this month. I've been getting into this talk section by section. Yesterday we did data fetching. The day before we did state management best practices. If you are interested in those topics, you can follow the live stream of yesterday or day before. It was a really fun discussion, so I highly encourage you to check it out. In today's session, we're going to talk about optimizing the performance for a YouTube clone. We're going to look at an example of a YouTube clone that I have, and we're going to talk about what are some things we can change, and we'll talk about it from a step-by-step. So we'll have a 6-part process of optimizing the performance. We're not going to do any code today because there's so much to cover, but the code of this is going to be in a dedicated YouTube video, which is going to be an hour-long tutorial. So if you want that, you gotta be a subscriber of this channel so you don't miss it. Stay tuned for that. But today we're going to talk about performance optimization. Before I get there, I have a quick announcement. Like you may be aware, I'm doing a raffle to React Summit conference, which you can see here in the ticker. Right here in the ticker. So all you gotta do is comment raffle in the chat and make sure that you are a subscriber of the channel, of this YouTube channel. And you will be entered to win 1 ticket to React Summit in Amsterdam on June 13th, 2025. The conference is going to be fully paid for you. All you got to do is show up and gain knowledge from amazing people at the stage. I am so excited because there is going to be a panel on the future of React, which I had a lot of fun attending and moderating in React New York, React Summit New York. But this one I'm even more excited for because React Conf, the official conf, is coming soon, and there's going to be some interesting announcements. So if you're interested in that, comment raffle. Thank you, Akash and Akanksha, for your entries. I got you in, and Harshal as well. Also, Rishi, hello, and Akash, welcome back. Good to see you. Kushal, how are you? Thank you for your entry. Okay, so let's get started. Before I even start giving you the concepts, I want to ask you, when you think about performance optimization, let's focus on React specifically. What are some things that come into your mind? It could be a bottleneck. It could be an improvement. Let's start with bottlenecks. What are some common themes that you have seen with apps because of which they are usually slow? So comment in the chat and let me know what are some common bottlenecks or problems you have seen in apps because of which they are slow. If you want to think of an app, of an example, think of YouTube. Unnecessary re-renders in the background, correct. So I've opened YouTube here just to show you an example, and my throat is not good today. But think about as I'm navigating, as I'm trying to maybe find a video, what do you think could be some bottlenecks here? Imagine that I have a slow connection. I'm also gonna do that as well. 3G connection. I'm gonna say slow. 3G connection is good. Reload this. Hard reload this. Unnecessary re-renders in background, re-rendering, large bundle size, yeah. Slow API response time, such as Reddit. Yeah, API response time, if that is slow, then really you can't really do anything on the front end, right? Use effects by themselves are not a problem, but when they run multiple times, they can cause a lot of renders, which can be a problem. Loading a lot of assets, sending a lot of data on the client and sending a lot of assets, so the client is spending a lot of time fetching those assets. And right now you see youtube.com is just loading and loading because I'm on a 3G. I'm on a 3G connection. I've simulated a 3G connection, so it's taking a long time for it to load. So the first initial page itself can be slow. What else comes to your mind when you think about a slow app? Unnecessary bloated JavaScript libraries. Yeah. So yesterday we actually talked about, sending, not sending, don't give me your garbage. The theme of don't give me your garbage, which is if you don't need to send a lot of data, don't send a lot of data. And JavaScript libraries can be a big part of making that bundle size huge, because imagine, we were talking about this in the live stream yesterday, where you have a use case where you need to probably just cache one or two fields, and for that you've added Redux. And because Redux is a huge library, you're sending a really big bundle size to the client, and that is unnecessarily bloated. Cool. So, okay, so you identified some places where, because of which an app can be slow. CSR counts. Client-side rendering or CSR by itself is not bad. right? You don't want to just remove client-side rendering from an app, because remember, client-side rendering leads to a lot of performance, lot of interactivity. So for an app that is highly interactive, it is actually a really good thing. So you cannot completely get rid of it. But the point is, what is the user first seeing when they see the page? Like right now, when I loaded youtube.com, it was actually completely blank. Whatever it may be doing in the background, for the user, it looks like I'm waiting a long time for even the first meaningful paint to show up, or even the first paint to show up. So that can lead to a performance issue. So the first thing you want to do is maybe show like a skeleton and then start loading in the skeleton. But at that point, let's talk about, like, when you think about using an app in 3G connection or in a slow computer, what are some optimizations do you think you can do? Where would you start? And this is actually a question that gets asked in what is system design? I don't know why I keep forgetting the name system design. This is a question that gets asked in system design. So I will ask the same question to you. Think about this YouTube app, and where do you think are some places we can improve the performance of this app? Oh my God, what is this? Oh my God, what? Okay, this is how I get distracted. Hunar, how's it going? Harshil, not putting an appropriate loader also feels slow. Yeah, so adding loaders is actually one technique through which we let the user know that something is happening and that they are not just waiting on a blank screen. So that is also a great suggestion. Oh, that also reminds me, we got to start today's goal. So, our goal today is, yesterday our goal was to reach one member, one paid member of the channel. Today, we're going to do the same. That's going to be our goal again today. Our goal is to reach one paid member today. And when that happens, actually, you know what? Here it is. I did a Q&A when we reached 2,000 subscribers, 1,000 subscribers. I did a Q&A when I reached 3,000 subscribers. How do you want to celebrate reaching 5,000 subscribers? Today's goal is to have one super chat. Congrats on 4K subs. Thank you. Thank you, guys. Thank you for the congratulations. Yes, we reached 4K subscribers. One step at a time, you know? One step at a time. We're going to get to 100K this year. You just wait. You just wait. But let's go. Okay, today's goal is one super chat. That's all we got to do. All right, so some people have some suggestions in how to improve the performance of an app. Splitting code for better SSR and dynamically loading invisible content and lazy image video loading. Okay, so there's a few optimizations here. Oh wait, there's another one. Splitting code. So code splitting, yes, for better SSR Code splitting is already a great way. We have been using code splitting for a while, and same with lazy loading images and videos. Does video lazy load as well? Video lazy loading. Preload. Yeah, so lazy loading images and doing a preload of the video is something that we've been doing as well, which is a great like first step itself. Dynamically loading invisible content. What do you mean by dynamically loading invisible content? What kind of content would you load? Using plain HTML, CSS for text space size. Yeah, that's already actually a really great tip, quarter 9, because oftentimes we think about like, let's go for React, but we don't realize that that comes with a cost, right? React comes with a cost. So if your site is literally just like a plain static site, you might as well just use plain JavaScript HTML. That itself is super fast. But oftentimes you don't have the flexibility to do that. Pagination based on users network. Yeah, so pagination actually is a great approach as well. And even without users network, what you can do is you can paginate the content. So even on YouTube, you will notice that the content is sort of paginated in the sense that it's infinite scrolling. So you can keep scrolling down, but it will only load one section at a time. YouTube video is already pretty optimized for its size, no? Yeah, absolutely. So, okay, great first thoughts. Let's get into it. But the first thing that I want you to remember is that when we think about optimization, we usually go for like, okay, like let me add like use memo, let me add use callback, let me like load my images, let me do all of this stuff. But I want you to remember to avoid premature optimization. Why? Because we may end up bloating our code so much with these callbacks, with these use memos, with this like stuff that may not even be necessary because our app is pretty fast by itself, even without any optimizations. And same with our components. Sometimes we think about our component, we think that it's taking a long time or maybe it'll cost a lot of re-renders, but we haven't actually measured it. So before optimizing, monitor first, measure first, and then see if your optimization has actually improved the experience or the experience hasn't changed at all. Before optimization, monitor what you're going to optimize and then optimize. Now, how do you monitor and what to monitor? There are a few tools available, but the main things that you want to be looking for is LCP, largest contentful paint, INP, interaction to next paint, and CLS, cumulative layout shift. These are 3 core web vitals currently of web standard. Now I'm going to ask you to raise your hand if you are unfamiliar with any of these. And there is absolutely no hesitation. Raise your hand if this feels unfamiliar. Just say unfamiliar in the chat. Or if this has ever confused you. And if you feel pretty comfortable with it, you say, I'm an expert. Own it. Own it, own it, own it. Unfamiliar with all of them. Okay, great. Thank you for saying. Akanksha, unfamiliar. Perfect. Thank you for saying. Hi, Sri Teja. content which is not visible or needed on first load, invisible, sorry, video by default load on client as watched. By default load on client as watched. Content which is not visible or needed on first load. Yeah, so invisible content, yeah, that's a good strategy. If you, or rather, what is it called? Not unnecessary, but content that's not needed in the first load, you can load it slowly and you can load it on the side. And that is also a great approach. Create app client instead of a website in case of YouTube. App client instead of a YouTube. I think that is actually a really big lift. So I don't know if I can put that down as a performance optimization. I'm sure there are creating a native app is much better than having a website because you have native capabilities for it. But I don't know if that can qualify as a performance optimization because that's a huge lift. And also, I don't know if there's like enough performance boost from it. Familiar but not an expert. Okay, cool. So let's talk about this. Thank you for saying, you all. So what is LCP, largest contentful paint? Let's actually open YouTube. And these are because these are core web vitals. They also come as part of your console itself. So at the bottom here, you'll see in the performance tab, there is a local metrics here, which is actually the core web vital. So if I give it a reload, and we'll see these kind of pop up. So contentful pane is showing up, and then CLS is showing up, and I'll show you INP in a second. So what is largest contentful paint? Largest contentful paint, and it also shows you the image itself. So largest contentful paint is when you're looking at a website, in this case, the YouTube page. What is the largest content, which is here, it'll be these kind of like these images, or rather video placeholders, what time it takes to load those. And why that is important is because that is the biggest chunk of content or screen real estate that the user is looking at. Okay, so how long does it take for the browser to paint that will show how slow the app is. In this thing, you'll notice that it takes 12 seconds because we are on a slow 3G connection, and therefore this is a slow metric, which means this is something that we can improve. And browser console is really helpful in actually showing this because it'll show you exactly how long it takes for each of those metrics. So this is super helpful. And then also it's indicated with red and green, which means you can improve it by looking at it. Okay, what does cumulative layout shift mean? So imagine that this app is loading and YouTube has actually done a really good job in actually minimizing CLS. But what this means is that when your page loads, if you have, imagine that you had nothing on this page, and as the image starts loading, the content starts shifting. So you have this placeholder, and then you have this another placeholder. And imagine if you had some form of like placeholder content here. As the content at the top shows, that content keeps pushing down. So that shift is called cumulative layout shift. Like how much is the layout shifting when content keeps flowing in, or when content loads. That is called cumulative layout shift. And that is a performance metric because the amount of shift that happens gives a jarring experience to the user, and you want to minimize the shift that happens. Therefore, the value of this is 0.01, which means very little shift is happening. And they're saying that the shift is actually happening in the footer, which is actually all the way at the bottom. So it's totally fine. So that's CLS, cumulative layout shift. And then finally is the interaction to next paint. So what interaction to next paint means is, if I load this page, you'll notice that interaction to next paint is actually blank at this point, and I'll tell you why. Okay, so the interaction to next paint means that if I click on a interactive element like this one, I click on this, how long does it take for this page to become, for that item to start showing up the next thing itself? So I clicked on an item and then I got the next page. The paint happened. I interacted and then the next paint happened. I clicked on the video and then the next page loaded and I saw some content show up. So I got some feedback from the UI that something is happening. That is called interaction, which is clicking the button, to next paint, which is seeing what's the next thing that's happened after clicking the button. And this says your INP value of 56 milliseconds is good. INP interaction is pointer, which is when you click on the video and something happens. So those are the three metrics. And these are the three core web vitals, as in every site is measured with these three metrics. Whether you're in JavaScript, whether you're in Angular, whether you're in React, whether you are in a different framework, this is what you're going to be measured against. And why I'm sharing this instead of React Profiler or things like that is because this is the absolute core web vital. Anything that is going to be on the web is going to have these three standards, regardless of the language that it's written in or the library that it's written in. So I'm going to pause here to see if there's any questions. Okay. I also want to remind you of code of conduct, that we absolutely do not allow or tolerate any form of sexism, racism, or any form of harassment comments. So please be mindful of that in the code of conduct. And be mindful of that in the chat as well. Hold on, I'm going to move this in here. Okay, there's a question here which is LCP when everything painted rendered on browser. LCP is largest contentful paint. So in YouTube's case, that is, think about the largest stuff that's going to be rendered here, which is this kind of like these images, this kind of stuff. That is the largest contentful. What is the biggest element that takes up the space? So you don't care much about this on the left because you care much about the item that's taking the largest real estate. So not everything, but the largest item. In this case, that single image took 14 seconds. No, it's accumulation of that that entire, like this entire segment, not that one image. Okay. And now with React, we know that there are some tools that are available to us for measuring the performance. We've got React Profiler, React Scan, and Next.js Analytics. What is the React Profiler? React Profiler is actually available as a browser plugin. I don't have it in, oh yeah, it's not available in incognito. Localhost, I don't know if I have this running. Let's just try google.com. Or let's try netflix.com, why not? Inspect. Console, profiler. So this profiler and components comes part of React DevTools, and that is a really helpful plugin for helping understand how long a React component took, why it re-rendered. It's really helpful. So it comes as part of the React DevTools. But why I open Netflix is because, oh, look at that. Why I open Netflix is because React Profiler is a profiler that can only watch for React components. So if you are not on React, it will say something like this page doesn't have React. So that is a, but this is a React, but this is specifically for React. So actually, let's try to run something. I'm going to run this app in the background and show you how Profiler works. React Profiler only works on sites using React. Exactly. Let's try state management. And while that is loading, I'll also show you React Scan, which is also available as an NPM module. And this is actually a relatively newer NPM module, but this is really cool because it shows you why an item loaded and why, like, what was the state change. So here, monitoring, view and live demo, there. And this is really nice because it shows you which component, let me zoom this in a little. It shows you which component took how many renders on average. So this is helpful in identifying like which component took how long, but also how many times it rendered. So if you have problems with use effect, this can be really helpful as well. And now let's run this React Profiler. Oh, I wonder if I may be able to do...
I'm Peppa Pig.
Jump into a world of fun when you play World of Peppa Pig, the mobile game.
Let's go 5173 React Profiler. Okay, there you go. So I've got Profiler in here, and this is a super simple app, but I think it'll show you why Profiler is helpful. So I'm going to hit record, and then I'm going to click on Update Age. Then I'm click on Update Last Login. And then if I stop this, it'll show me that this component took this long, 1.4 milliseconds. But what's helpful is that it also shows, like right now I don't have a lot of components, but it also shows the slowest component itself. And another thing that I really like about this is it comes with components. And I think in yesterday's app, you might have seen that if you click on this highlight updates when components re-render, and if you click on this, it will show you at the top that a component is re-rendering and how many times it re-renders, which makes it super easy to identify that a state change leads to other components being re-rendered and how one state change may be causing other components to re-render. So it's really helpful that way. Another thing is that it also comes with this like kind of like Redux like state change store as well. So that's really helpful as well. And in some place, it also showed you why a component re-rendered. So if I update less login, somewhere it showed you that. And it also shows you if an effect ran and what changed in the effect. So React Scan, React Profiler, two React tools that are super helpful. And then if you're using Next.js, you also get Next.js Analytics as well, which can be helpful as well. But that's using for Next.js apps. Okay. When we look at the code, when we look at the React code, a standard way to kind of optimize the code is by using use memo and use callback. And where you have to put that use memo and callback is how you can use React Profiler and identify where are the places that a component is slow. Usually, you'd want to put use memo and use callback in a place where you have a lot of computations happening and you want to reuse that value. So use memo is a hook that lets you cache a value, and use callback is a hook that lets you cache a function. And why I said monitor first and optimize later is because you don't want to put use memo and use callback everywhere. You would want to identify which components are slower by looking at the profiler or React Scan, and then adding use memo or use callback in those places. Now, with React 19, there is also a new plugin called React Compiler, which works with React 19 really well. And I think it works with React 18 as well. With React Compiler, you actually get memoization out of the box, so you don't need to add use memo and use callback anymore. But if you're on React 17 or lower, you will still need to add use memo and use callback. React 18 and above, you can use React Compiler as a plugin. So first place in optimizing a React code is first finding out where are the bottlenecks by first looking at your web vitals, then looking at React specific things with Profiler and Scan, and then either adding the memos, the memorizations using the hooks, or with React Compiler. Now, when it comes to an app, there is a ton of stuff that we can do. Here's just a few things that are possible. I'm going to pause here because there's a lot of content on this, so you can read this if you want. I'm going to pause here for a second. And if any of these terms is unfamiliar, just ask me in the chat. I know LCP, not the rest. LCP is not here. Okay, how parallel data fetching promise.all and also concurrent rendering. Yeah, so parallel data fetching is helpful because instead of waiting for, so imagine in the case of YouTube, right? Instead of waiting for each resource to finish rendering or like to come back and then call another resource and then wait for that and then call another one, you could rather parallelly fetch data, and this way you'll have most of your data ready when the app is almost ready to be when the app is ready to render. So instead of waiting one by one and calling an API one by one, you can parallelly fetch APIs that can be called that don't have dependencies on each other. In the case of YouTube, you can imagine that you need to fetch these videos and then you need to fetch these shorts and then you need to fetch like, I don't know, something else. So you could fetch these kind of like highlighted, actually like imagine that you have the sponsored videos at the top and then you have this shorts and then you have like some organic content. So you could fetch all of these in parallel because they don't have a dependency on each other. They may have a dependency on user ID, but they don't have a dependency on each other. So this kind of content you can fetch in parallel. This way you don't have to like wait for this to finish and then load this and then so on. So let's talk about these one by one. Tree shaking. Can anybody tell me what tree shaking is? Tree shaking has been around for a while. Can anybody tell me what tree shaking is? YouTube also loads way faster second time due to caching. Yeah, exactly. And that is also part of a optimization as well, which is called caching. So I've written that down as part of caching API response. You also load the assets, preload the assets on the you also cache the assets on the client as well. So less requests you need to make the second time. Okay, can anybody tell me what tree shaking is? Tree shaking, modifying DOM, appending, removing maybe. Is tree shaking for modular import, removing unreachable or unnecessary code from bundle. Exactly right. Harshal, you got it right. Tree shaking is removing code that is unusable or not used and removing it from bundle. So imagine that you have like a bunch of, you have a code and you have like a bunch of functions added, like you've added like, imagine like you have like a calculator function and then you've added like add 1, add 2, add 3, add 4, add 5, and then in your file itself you're only calling add 1. So what you can do is, instead of sending all of those functions add 1, add 2, add 3, add 4, add 5, you can only add the content that is needed, which is add 1, the function add 1, because that's the only function that's being called, and forget about the rest of the JavaScript. So this way you've reduced the bundle size that you're going to send. Because if you're going to send all of that code over to the client, that's a lot of useless code that they're not going to use. So what you can do is, a lot of bundlers, like bundlers today, like Webpack, allow you to tree shake, as in remove anything that's dead or unused and only send the good code that is being used. So imagine a tree like shedding all of its like dead leaves and dead flowers. It's only keeping what is useful and what is fresh. That's the same idea. That's why it's called tree shaking. You're only going to keep the code that is used, and that reduces the bundle size. That's tree shaking. This has been around for a while. This is not something new, but now it's now a standard, but it's very helpful in, first of all, removing dead code itself, removing code that is not helpful. Parallel data fetching, we already talked about, and lazy loading also has been around for a while, and I'm sure most of you know. So tell me in the chat, what is lazy loading? Webpack does that, right? Yes, Webpack does that. We rollup have tree shaking. Yes, exactly. Webpack, Vite, rollup have tree shaking. This happens automatically on build time using compiler tools, using tools like Webpack. They automatically do it on build time. You can also configure them. Okay, so what is lazy loading? Loading only when UI is visible. Lazy loading is when you wait to load something until it's used. Yeah, so I think, so you got it right, Jacob. Lazy loading is when, imagine on YouTube, you have hundreds and hundreds of videos, right? At the bottom here, you'll see that there's like, I keep scrolling, but there's more and more videos. I hope this is scrolling. All I see is football. But you see, like, as I'm loading, I'm getting more and more videos. But there, for a brief second, you will see that there's like a little gray placeholder. So what YouTube is doing is, it's not loading all of that video content at the same time, or all of those thumbnails at the same time. It's waiting until the user has reached a certain like viewport length, a certain time, and then loading images in so that the user kind of feels that all of these images are present, but actually does not increase the time it takes to paint the first, to do the first paint. And why this is helpful is because it prevents loading unnecessary content. We talked about this yesterday. Don't give me your garbage, right? So if you don't need videos right now, you don't need images right now, you don't want to load them, which is why we lazy load them. So if the user will need them, we'll load them. And how do we know that the user is going to need them? We'll know that by, there's a couple of different ways to know. We can check at what length of the viewport is the user in, and once they have reached that certain length, we'll load the rest of the content preemptively, because we think that they might come to that. So if they've seen this much content, at this point, we'll load more content, and we'll make sure that the user has something to see as they start loading in. And so you'll notice that even if I'm scrolling super fast, I actually still, if I scroll a little bit slower, you'll see that the videos are pretty much constantly showing up, right? Like the images are constantly showing up. That's because YouTube understands that once I've reached a certain length, I might still continue scrolling. So YouTube will lazy load more images. Okay, let's talk about optimistic UI. I think this is one that confuses a lot of people. So tell me what you understand by optimistic UI. What does that mean to you? How many slides do I have left? Oh, okay. After this, we're going to do an example. Cool. This is fun. So what do you understand by optimistic UI? And to think about optimistic UI, think of an example of liking a post, and that might give you an idea of what it means. Okay, I see that some folks are writing here. I'll give you maybe like 2 more minutes to write comments about what is optimistic UI. Oh, that's a great question, Ankit. I'll answer that question in a second. Okay, so let's see what we say. I'll always get the data, and so let's update the UI right away. In case error happens, fall back. And yeah, I think you've got the gist right. Instead of waiting for data to update and then update on client, render first on click. Showing UI changes before network requests. After the user does an action, update the UI immediately, assuming it was successful instead for waiting for the action to complete. Exactly right. You got it right, Jacob. What if the UI is dependent on the... Okay, so yeah, so Jacob, you got it right. Exactly, perfectly described. So what happens with in optimistic UI is we want to complete an action, and remember that we want to show to the user that an action has completed, right? We want to show to the user that their interaction was successful. Remember, what we're trying to optimize when we think about performance optimization, especially in the client side, is we want to show it as fast as possible to the user that their interaction was successful and that something happened when they did something. Honestly, like if I can summarize what we're trying to do on the front end side is really just when something happens, we want to show to the user as fast as possible that something else happened, right? That meaningful stuff happened. Optimistic UI is the same thing. It's a path in that direction. Let's say that a user hits the like button on YouTube. You want to show to the user at that point, what you are doing in the background actually is when you hit the like button, you have to make a request to the API. You have to update in your database that like is increased, and then you want to come back, and if you got a success, then you're going to increase the number of like button or in the UI, right? So you're going to wait for that network call. But the user at this point expects you to do it right away, right? They don't care that you have to make this request call. So what you can do is, for the client side, you can update the request, or you can update the number optimistically, which is assuming that it was successful. So instead of 2 likes, you can now show 3 likes, and then you can make this network call request in parallel. And while the user still sees that their like button or their like has approved, it went through, and let's say that something failed, you can actually now show a fallback, which is an error case scenario, or rather a fallback scenario, in which case you show that the counter did not increase, right? Or you can show an error message. So, but to the user, you have optimistically shown that this is this went through. Now, where you can do optimistic UI is a consideration you have to think about, because you can't use it everywhere. Like if you're doing a payment processing, you can't show to the user that you've paid and then show them that you have not paid. Or if you're showing them their bank balance, you can't show them that they have like, oh, $100 million, and then show them that they have no money, right? So you have to think about where you can do optimistic UI, but it is really helpful in places where you have to show like these micro interactions, such as liking a button, or you have to show these interactions such as like reviews, number of reviews, or you have to show them that their comment is posted, right? Those are places where you can use optimistic UI. And use optimistic is a React hook introduced in React 18 that can help to create optimistic UI. React 18, right? Yeah, I think it was introduced in React 18. Okay, so the question is, what if the UI is dependent on the API response? Still, can we use optimistic UI? Yeah, so basically that's exactly when you want to do a UI, when you want to do an API response. Like when you want to do a optimistic UI, when you're waiting for that API response, it could be long, and so you want to show to the user while you're calling the network. In React 19. Okay. Yeah, thank you for letting me know. Okay, which of these do you want to talk about next? I don't know if we should talk about all of them, but let me know which of these you want to talk about next. I'll pick maybe 2 or 3, and then we'll get into the example. Okay, lazy loading we just talked about, so maybe go back a few minutes, lightify, and you'll find lazy loading. Concurrent rendering, oh, that's a good one. So deep core algorithm. What? It depends on what kind of API response. If you can reasonably guess what the response will be, success to a comment user just entered, then optimistic UI is great. Yeah, exactly. Low stakes typically. Okay, let's talk about concurrent rendering. Concurrent rendering is actually a React 18 concept. And then I did a whole talk on concurrent rendering.
Too much Mac clutter?
React and batch state updates here. We render once at the end, and this is better than click function. Support features from the lens of the box improvements such as automatic. React has every really good rewrite. Let's recall what server. Now, what if this is because server with suspense you can skeletonize to make performance by marking. Talk to a suspense on the start and use it perceived later. Component doesn't have to pull down the entire render of your deferred value later. Some of them are React 18. All right.
to keep the browser responsive, generate unique
Trying to
IDs
find the
for
most
new APIs.
appropriate part, but I think I'm going to share from here. Instead of batching, I think this will be helpful. Okay, let's do this one. Concurrent rendering. Okay, but I want to show you actually the blog post on concurrent rendering to help you understand what concurrent rendering is. Okay, I wish there was a better way of like showing where in React, like a better way of talking about concurrent rendering, but let's just focus here. So, concurrent rendering is basically how streaming works and how suspense works and how these new APIs, which you may have heard of, like start transition and use transition, works. So what we do is that what used to happen initially is that when React is rendering, it will render everything all by itself, like to go from the top, render everything. But with concurrent rendering, what we can do is we can identify some parts of the app that are more important than other parts of the app, and we can let React render a part of the app while letting it know that the other parts of app will come in later. And when those parts come in, it will actually plug in that data in, stream that data in, and render that part while the rest of the app is also finishing rendering. This multiple pieces rendering together is called concurrent rendering. In order to enable concurrent rendering, you don't need to do anything with React 18. This is a new paradigm shift in React 18. You don't need to do anything. You have APIs that you can use through which you get concurrent rendering out of the box, like use transition, start transition, through which you basically identify which parts of the app are more important, or which parts of the app are less important and should wait a little until the rest of the app is can prioritize loading. And I think in this, one of the example that I showed was like this part. This is how we introduced suspense in React 18. So imagine that this part of the app is more important. So this could be like your sidebar on YouTube, and then at the top this could be your videos at the top, and at the bottom maybe could be like less important stuff, like such as comments. So imagine this is exactly like this page, right? So there is YouTube video itself, the player itself, and then at the bottom there's the comments, which may not be that important. So what we can do is we can mark this part as in a suspense boundary, and we can say that this part should load later on, and then once that part is ready, once the UI has fetched calling the comments or the reviews or whatever, it can then stream in that data later using suspense. So with suspense, we've marked which part of the app should be streamed in later, and this is called concurrent rendering. So instead of like rendering from top to bottom and just like waiting for a section to load, we can concurrently render certain parts of the app. And that's concurrent rendering. It's available with React 18, you get it out of the box if you adopt React 18 features. That's what this is about, gradually adopting concurrent features such as suspense, server components, automatic batching, transitions, suspense boundaries, and so on. And then rendering to pipeable stream as well. Okay, what else? Okay, then defer scripts. Yeah, so defer scripts is actually a really good one. I'll show it to you. This is a okay, I want to show you a good example maybe. Okay, maybe this one. Okay, I think this example is very clear in showing what defer does. So if you have a script like example.js, it could be actually like a heavy file. So you want to do something that you don't want to have on the first load. You can defer the loading of that until the rest of the scripts have finished loading. So this can be helpful if you want to load certain like not internationalization, but certain like libraries, like maybe for date, maybe for maybe a third-party library that you don't need. So you can defer certain libraries and let them load at the end until more important libraries have, more important scripts have finished loading. So all you got to do is attach a defer attribute to the script itself, and that'll defer the loading of that. So that's what defer scripts is. And this can be helpful. Let's say that if you have a page and you're loading like moment library, so you can defer to moment library so it loads at the end. Or maybe if you're loading fonts, that may not be useful to load right away, so you can load it at the end. Are script tags loaded sequentially or concurrently? You load script tags one by one. I think we can do a session on actually on like scripts as well, because there's a bunch of attributes that you can assign to scripts, such as async, which actually leads to scripts being loaded in parallel. By default, they're loaded sequentially, but you can also load them in parallel, or you can defer certain scripts using defer. I think that could be, and then you could have fetch priority as well. So that could be a good session as well. And if you want that, let me know. Okay, any last topic here that you want to cover? After this, we'll get into an example of video player. if there is no other questions, actually, I'll give you like a minute or two to answer. Okay, if there is no other question, then tell me, what does it mean when we say caching with SWR? What does that mean? What is SWR? SWR is stale while revalidate. Cache API response, in the caching API response instead of storing in the local storage, what we can use is that it persists among reloading too. Caching API response instead of storing in the local storage, what could use is the persist among reloading too. Not quite. Fetch data once and keep it in memory until time specified or reload. Precisely. Is SWR React specific? It's actually a concept that has been popularized by Next.js. Let me show it to you. SWR. Okay. Oh no, not this. Oh. Okay, I think this is helpful. SWR, what is SWR? It stands for stale while revalidate. HTTP cache invalidation strategy. So it is used by Next.js, popularized by Next.js, but what you can do is SWR is a library, which is the library that Next.js has popularized or created, and it provides React hooks for data fetching built upon the stale while revalidate strategy. But what's important is that it's actually used to cache, but it stores data for a specified amount of time and serves this data to users who request it within that period of time. So SWR is kind of like you go to a buffet, like caching with SWR is kind of like you go to a buffet and the buffet food is ready and prepared for you. So you just go and fetch it yourself. But the server, the restaurant people, they make sure that the food is heated or the food is refreshed every like 5 minutes. So they make sure that the food is hot. So regardless of what time you're fetching the food, it's usually hot or hot-ish, as hot as it can be within 5 minutes. That's what SWR is, caching with SWR. The problem with caching without SWR is that it's kind of like going to a restaurant where there's buffet food. So if you are the one who has who is eating food just when they have refetched or like when they have updated the food, or when they have just added new food, you get the hottest food, right? But if you are somebody who comes in later, then you get food that is cold or is like starting to go bad, right? So depending on how often they update their food, you may be getting cold food or you may be getting hot food, right? But with SWR, what they do is every 5 minutes, they'll periodically update the food so that you usually get the hottest food available. So it's the best experience for the user. Oh, this is interesting. So if the data is stale, SWR revalidates it to keep it fresh. By default, SWR automatically revalidates the data in 3 cases. Every time the component is mounted, even if there is data in the cache, it revalidates. It revalidates when the window gets focused. It revalidates when the browser regains its network connection. Okay. Old data until satisfy a certain condition to refresh those data. Usually that condition is time. I don't think there is a different condition. I think it's just time. But I could be wrong. Okay, let's take a pause here because now we're gonna, after the break, we're gonna take a look at Video Player, which is the YouTube app. I will have, hold on, I will, oh, did I skip a slide? Oh no, hold on. Unskip slide. We're going to look at a video player at the end of this break, but let's take a really quick short break. We'll be back in 5 to 10 minutes. Let's do 10 minutes. 11:30, let's come back at 11:40. Let's take a quick break. And then after the break, we'll take a look at how to optimize a video player. I'll be right back. Okay, we're back from the break. I have my chai and I have some energy. I came back from India recently, 3 days ago, 4 or 5 days ago now. Last weekend actually. Oh my God, can you still hear me? Yes, okay. Yeah, came back from India like 4 or 5 days ago, and ever since coming back, I have got a stomach bug, and now I have a little bit of fever. But I wanted to make sure that I come here and share this with you because it means a lot that you all show up and you all are interested in learning this. So I wanted to show up with my best self to show this for you. I pour my heart into these streams, and if these streams have been helpful for you, consider becoming a member. It really, really helps my channel. And also, we are still looking for our first MVP of today, which is the super chatter of today. Our goal is 1 super chatter today. So let's see who's going to be our MVP. In the next few minutes, we're going to be going over a video player component, which is actually kind of a YouTube clone. So we're going to do that, and we're going to talk about the concepts of optimizing the app. The code is going to be followed later in a YouTube video. Today we're going to discuss the topics, but if the topics make sense to you today, you're going to really, really enjoy the code, and it's going to make a lot more sense. So that's why I wanted to not do the code today, but rather just talk about the concepts. That's weird. This is so long. Okay. Better. Much better. Okay. Are you in the Meta React team? I'm not. But I am on the React working group, and I have spoken at React conferences. And actually, I'll be at the official React conference this year too. It's not publicly announced yet, but I'm telling you guys. Okay, cool. So we talked about, before going on a break, we talked about a bunch of different performance optimization ideas, right? Lots of different ways you can optimize your performance. There was even a whole slide with a bunch of different words on how you can optimize your app. I want you to name at least 2 different optimization techniques and put them in the chat. Tell me 2 different optimization techniques you can use to optimize your React app. I'm sure we can do multiple, but we want just 2 for now. Anas, welcome. Lazy loading, memoization. Yes, correct. What else? What other techniques? Throttling and debouncing, yeah, those are good techniques as well. We didn't really talk about them today, but those are good techniques too. Lazy loading virtualization, correct. Use memo, use callback, memo, that is correct. Like memorizations of the code. SSR, correct. We talked about them a lot, server-side rendering. What else? What other optimization techniques come to mind? We also discussed one of them, that is a React feature, came in React 18. Optimistic UI, correct. You got it, Ankit. Image compression, that's a great one. Image compression for sure. I don't know if we talked about this. I don't know if it was on the slide, but image compression is a great one. Concurrent rendering, you got it, Harshal. Exactly right. Concurrent rendering, a React 18 feature, something that you can opt into, but you get out of the box with React 18. You can opt into with React 18 features, but you get out of the box with React 18 and helpful in prioritizing some parts of the app over others. So overall, let's recap. This is what we talked about just a few minutes. Oh wait, I'm not sharing. This is what we talked about just a few minutes ago. These are some techniques for optimizing your app, okay? Now, keep this in mind because we're gonna come to this a few times. So keep some of these in mind, like parallel data fetching, lazy loading images, concurrent rendering, managing data better, pre-rendering some of your routes, leveraging the CDN, which is actually a really big one, especially for an app that has video player, deferring some scripts, suspense for progressive loading content, optimizing images, caching API responses so you're not refetching the same videos over and over again. So now with that in mind, let's get into the video player. So I've created a YouTube clone. The URL is here in this QR code. I want you to open this, click on the first video, try out the app a little bit. It is an unoptimized version of the app. Try out the app a little bit and click on the first video and post a comment for me. And I also have this open on my app, my page, and I'm going to share the link in the chat as well. Or at least try to. Okay. Okay, here is the app. You can open this on the computer as well. You'll notice that this app has a few issues. Forget about the layout on the left. Let me demo this app actually, why not? So this is the app. If you open this in full screen, it'll look better than what it looks like on a smaller screen. This is actually a vibe coded app, so don't worry even about like the performance of it or the layout kind of weird on the left. The idea is that we want to understand what are some techniques we can adopt in this app to make it a better optimized version of this app. Now, I want you to click on the first video and post a comment here. click on this building AI powered applications with React and OpenAI and post a comment. And when you've posted a comment, please put done in this YouTube chat so I know that you posted a comment and I can refresh the page. Done. Thank you, Aziz. Okay, let's take a few more minutes. All right, I'm seeing some comments come in. All right, so for those of you who added comments, thank you so much. I see some comments coming in, which is awesome. Now, my question to you is, put in the chat, what do you think are some problems with this app? We're going to optimize the performance of this app, right? So as of now, what do you think are some problems with this app? So maybe like browse the app and see what issues do you see? If you were to improve the performance of this app, and if this was an interview question to you, where would you start? And actually, the rest of this exercise, we're actually going to imagine that we're doing an interview question, data structures, not data structures, what is the thing? System design. Why do I keep forgetting that? System design interview question. So imagine that you're in a system design interview question, and the question given to you is that you have to improve the performance. Actually, this is not a system design question, but imagine that this is the interview question that's given, which is actually a common question. Improve the performance of this app. You don't have to write any code at this point, but I want you to tell me what are some places where you can improve the performance and what are some issues you see with the app currently. I see that loading entire video at once and loading all video at once, those are two really good points. YouTube does this really well, where it loads some videos and then it'll only load the next video in like the actual video that you want to play in chunks, and that is a good optimization we can do. What other things come to mind? Okay, we're going to write this down. Unoptimized YouTube player. So you said loading. I'm sorry I have to leave. Chelsea's playing European final. No problem. Thank you for joining us. Loading all videos at once and loading the whole video at once. Right? So we're not optimizing how we load the assets. Lazy loading videos thumbnail. Yeah, so something that we don't do is there is no lazy loading. No lazy loading of assets such as thumbnail. And if you are joining this after or later, so here's the question we are working on. What are some problems with this video player app? And this is the video player app. Try this video player app. Oh, thank you for sharing, Aziz. Even in this case, the browser streams the video. Yeah, I think that is browser's default behavior, but we can still improve it. And actually, that's just like the assets loading in, but we haven't done any optimizations in it. There's also no memoization. So if we are calculating something, we're actually doing it all together. And this is typically as you write an app, and if you haven't thought about the optimization of the app, you typically don't start with memoization. So we don't have any memoization in this. We actually don't have any caching in this as well. So even if you load the same app, same video again, we reload the entire asset for you. So, and then we don't store any images as well in the cache. So we're not caching anything. There's no caching of the images. There's no caching of the videos itself. Another thing you might notice is that image assets are not optimized for the browser experience, which means that if you are on the web browser, you'll see the same image asset as if you are on the mobile browser, as if you are on, and same as if you are on tablet. So the image assets, or like the thumbnail assets, they are not optimized for which browser experience you are on. Why that's important is that on the mobile, you need a much smaller image, but on a web browser, you need a much bigger image. So if you're sending the same big image on mobile, you're wasting a lot of data. You're wasting a lot of bandwidth. So don't give me your garbage. Don't give me assets that I don't need. Using web-friendly video format, yeah, instead of MP4. And one thing that I don't know if you've noticed is that we have like what? Small 6 or 15 images right now. But if I reload this, I'm gonna give this a hard reload. I actually don't have any memoization in this. Any pagination in this. So no pagination or virtualization experience. So what happens is that when you load the page, all of those come together at the same time. So there's a ton we can do in this, right? So let's talk about that. I think because this is a video player, we can have a really big lift off if we just focus on the image and video assets itself. Like even if we don't do anything else, even if we just do the image and video assets, that'll be a huge win itself. So let's talk about performance. Let's talk about video, image and video assets optimization. And this is because it's a video player app, we're focusing on image and video assets. That doesn't mean that it's going to be same for an app that you're working on. Maybe you have a form app and you don't have any image and video assets, or maybe you have one image. Then maybe the most important thing for you is not the image and video assets, maybe it's something else. If you have an audio player app, your most important asset at that point is audio. If you have a streaming software, your most important asset at that point is the stream that's coming through, the video stream that's coming through. So in your app, you got to think about what is your use case, what is the biggest content that you are dealing with. For us, it's the image. So step one, let's talk about image and video assets optimization. I think you guys already had some great tips here. So let's talk about them again. What are some things we can do to optimize image and video assets? Use WebP format for low spec devices, absolutely. So you already had this suggestion, which is a great suggestion, which is use web-friendly formats such as P4, such as WebP. Exactly. What else? We talked about lazy loading as well, right? Lazy loading images. Let's talk about how we're going to lazy load images. We've been talking about this for a while. There's a few different ways of doing lazy loading. I'm going to show you the JavaScript way, and then I'm going to show you the lazy loading. And then, I don't know if React has image lazy loading. Okay, so JavaScript actually comes with an attribute called loading equals lazy that helps to lazy load an image. It's actually super simple with just JavaScript itself. So you have a image loading equals lazy, you add that on the image attribute and it will automatically defer loading of images that are off screen until the user scrolls near them. So super helpful already. Then we also have something called intersection observer that kind of does the same job. Okay, so images can be lazy loaded, but with the help of intersection observer, and this is actually an interview question as well, which is implement lazy loading of videos or lazy loading of a list or like virtualization of a list. So that's an interview question as well. What you can do is with the help of intersection observer, you can understand where in the viewport is the user at, and with that you'll be able to understand if you need to lazy load the image. So lazy loading images first with loading equals lazy tag, but also in Next.js, you can also optimize image assets using the image component itself. And actually, I don't know if I have code, but it's okay. Let's not look at code right now. You can also optimize image assets using the image tag itself. And I'll show you Next.js's image tag. Oh, we also want to talk about dynamic imports. There it is, lazy loading. There, images. Okay, so the image tag in Next.js, and this is super helpful if you're using Next.js already. What it does is it gives you optimization, so it correctly serves image sizes for each devices. Visual stability prevents layout shift. This is what we were talking about, LCP. Faster page loads, which is only loading images when they enter the viewport. Asset flexibility, resizing images on demand. So the image tag actually does a bunch of things that we talked about are not optimized here, like which image to deliver for which browser. And so we can also use Next.js's image tag for optimizing the image experience. So again, the things that it does for you is provides visual stability, as in lets the browser prevent cumulative layout shift, CLS, which is a core web vital, because it creates a placeholder for it and then lets it stream in the image once it's ready instead of shifting the image. Optimizes the image and correctly serves the correct modern image format like WebP, which is what we were talked about. Asset flexibility, which is if the image is on a smaller device, it'll give you a smaller device, but if the image is on a bigger device, it'll give you a bigger device. Okay. And then the other thing we wanted to talk about is dynamic imports. Okay, dynamic imports is actually really cool because what it does is dynamic imports is a composite of React Lazy and Suspense. It behaves the same way in the app and page directories allow incremental migration. Where is the content about dynamic imports? Okay, dynamic imports is actually the same thing as lazy loading for images, but for JavaScript files. So what you do is you've got import dynamic from Next Dynamic, and then you add your component within it. So this is a server component, but just imagine any component here. So you got dynamic import, and what it helps you do is it helps to prevent loading a component, especially if it's a server rendered component, because that's not on the client already. So it helps to lazy load a component or prevent the loading of a component until it is actually ready to be viewed. So that is something that we can do as well, which is dynamic imports using Next.js Dynamic. We also did not talk about using a CDN for asset delivery. So instead of shipping the assets within the client bundle itself, we can use a CDN to deliver those assets. What other things come to your mind? There is no DRM protection for the video. That is a good one. I don't know if that's not a performance optimization one, but yeah, that's a good one. What other image optimizations can we do? We've also been talking about like streaming the video in, right? So loading the video in chunks. And I'll show you a working example in video for this because this is really fun. Caching, yeah, caching the assets is an important one. Caching images. So I think that's a really good list of things we can do for image optimizations. What do you think should be the next step we should do for this page? Where do you think we'll get the most sort of benefit in optimization? What is something else we can do? So we optimize the images already. What else can we do? Pre-process given video into different video qualities to be delivered as per demand. Yeah, infinite scrolling or pagination. That's a great one. So let's call it splitting code. It's not let's call it chunking, and this can include lots of chunking stuff, right? So we're gonna put lots of chunking stuff in this. Why? Because we're currently loading everything together, but there's a lot we can do here. So somebody said pre-process given video into different video qualities, quarter 9, that's a great one. We were also talking about splitting the video into chunks and only sending chunks instead of sending the whole video together, which is something we can do, which is splitting the video in chunks. And I think infinite scrolling or pagination is actually part of chunking the page as well. Pagination of, so we can, instead of showing the entire page, we can show a certain section, and then as they load, we can show more and more sections. So this is chunking the page. We also talked about code splitting with dynamic imports. So this is removing any unused scripts. And this can be helpful, especially like if we have things like instrumentation, or if we have like analytics, or if we have like AdSense or something that we want to delay a little bit until the video has loaded, right? These things can be delayed a little so that the user actually sees the video, and we can lazy load these scripts later. Changing video quality dynamically according to network. Yeah, so that can be part of network optimizations as well. Network optimizations, which is delivering video quality as per bandwidth, right? So that means you start off with like 420, and then you like, what is it, 480, 460, 480, and then you go on to 720 and 1080 as your bandwidth increases. And same with image assets, progressively become better, become sharper or high res. And pre-process video into different qualities to be delivered as per demand. Exactly. So that can be part of, yeah, network. But you know, one thing that we didn't talk about so far is actually the page layout itself. We've been talking about three core web vitals, right? The LCP, the CLS, and the, what's the third one? CLS, LCP, and actually, let's do this. Let's do this pop quiz. What are the three core web vitals? Put that in the chat. Three core web vitals. FCP, interestingly, is not a core web vital. I think it's a common misconception. It is not a core web vital. We talked about core web vitals a few minutes ago in this stream, so go and scrub back if you need to. It was one of the first slides. We should do a mock interview on this stream. I think that will be fun. Let me know if you guys want to see that. LCP, CLS, INP. Correct. And who can name the full forms? What do these stand for? You're right, Harshal. I really want to be able to like award points, but I don't think that YouTube has a way of doing that, you know? Like fan points. That would be so fun. Largest content paint, correct. Largest contentful paint. LCP stands for largest contentful paint. CLS stands for cumulative layout shift, and INP stands for interaction to next paint. Interaction to next paint. So what they mean is largest contentful paint. Why we're talking about this is we can server render some stuff so that our largest contentful paint is shorter. Why? We saw that YouTube does this as well, where you load the shell and then you load in the rest of the videos later, right? So we can server render the content. We can server render the initial page. And why that's helpful is because we can have the initial content. Instead of putting all it on the client side, we put some stuff on the on the server. And that helps in not only increasing the performance, but also SEO as well. And the user sees the first page faster, thereby increasing the core web vital performance as well, which is LCP, largest contentful paint. INP, interaction to next paint, is how long it takes to, when you click on something and it opens, right? For that, what we can do is prefetch trending videos and this helps to decrease INP. Why? Like if you know that there are some videos that people would likely watch, you can actually prefetch them or preload them, and that will help to actually already have a video loaded, so you don't have to start from scratch, especially if you know that a video is being watched multiple times. That decreases INP. Server render initial page decreases LCP because you have kind of like a shell already ready. Then we can also perform the heavy or like the heavy data fetching that we need to do on the server itself. So we can data fetch on the server for initial load, which means that if you want to send certain data to the user, like for example the sign in, or if you want to send them the first like home page, which will probably be the same for everybody, we can fetch that on the server itself. And then we also talked about like this skeleton UI for thumbnails, right? Which we can do using suspense. So what we want to do is that when, for example, there is like a placeholder UI, right? Sort of skeleton UI, let's give it placeholder UI. So while the video is loading, we can show them a placeholder UI, and as the video loads in, streams in, we can add the data in, or we can load the video in using suspense boundary. So we can add a suspense boundary for that. So that is a lot of optimizations to do. I think this is such a great place to, like if you can show something like this in the interview itself, this is such a great way to display your knowledge of performance optimizations by going from non-optimized version to an optimized version and talking through your logical reasoning. Now, this is the point where we're going to stop today's live stream. If this was helpful for you, let me know in the chat if this is something you like, and if you want to see something, if you want to see the code of this, whatever we discussed in a video form. I have the code ready, but I'm wondering if this would be helpful for you. So if that is going to be helpful, let me know in the chat. If I have 10 people who say that this would be helpful, I'll make it into a video. There's 416 people watching this. If 10 of you say this is going to be helpful, I'll make it into a video. This web app surprisingly has score of 91 on Web Vitals and Chrome Lighthouse. That's probably because it doesn't have a lot of content. I mean, I think it's already at a really good, like, it's already at a not such a, yeah, right, like not such a bad place already, but this is also not a, like, real app. The videos are all kind of not working, like it's all the same video. Honestly, like, I don't think any of these other videos will work. Yeah, it's all the same video, so the asset is just one. That's why the score is good, but I'm sure once I add the actual videos, it'll be a lot worse. Like the thumbnails are all the same, so it's a cheated video. Okay, let's see if there's any other questions. Any questions I can answer before we end today's stream? And was this helpful to you? Okay, with that, we're going to end today's session. Thank you so much for joining me. I hope this was helpful. I hope you learned something new today. If you did, put in the chat if there was something new that you learned and if this was helpful. I will not be streaming tomorrow, and I'll not be streaming for a while because I'm traveling to Amsterdam next week. I will be at React Summit. Do not forget that we're doing a raffle. The link, the description, the chat description is here. We're doing a raffle giveaway. So if you're interested in a free conference ticket to React Summit in Amsterdam on June 13th, 2025, then comment raffle in the chat or in the comment section, wherever you see this. And in order to get entry into raffle, all you gotta do is make sure that you're a subscriber to this channel and that you've entered the word raffle in the chat. I got Quarter9's raffle entry. Thank you so much. I will be announcing the winner on Friday, May 30, Friday. I will be announcing the winner. I won't be live streaming for a while because I'll be traveling to this conference and I'll be preparing a talk on how to become a staff engineer. If you want to see that talk in a live stream, let me know as well. I would be happy to do that. But I will see you guys very soon. Thank you so much for joining me, and I hope that this was helpful. I appreciate your support. Thank you for becoming a member as well and for becoming subscribers of this channel. I will see you soon. Bye, folks. Stay healthy.